So good morning, everybody. Thank you, Brian, for that introduction. I'm going to talk about DAFNI specifically, an introduction to what we're doing. So I'm, as Marion said, Brian Matthews. I'm the project lead, and I'm from the Scientific Computing Department at, DAFNI project lead for the Scientific Computing Department at STFC. So, which I'll explain a little bit our role later in the presentation. So I've got my slightly getting my windows over each other. Okay, so I'll start with first a little bit of introduction with a couple of the challenges we have. And last year when we did our launch event for DAFNI, we had Sir John Armitt visit us and speak. And he said, data is now important to UK infrastructure as concrete as steel. So a illustration of the kind of the importance of data and computation as a central part of infrastructure to the whole national infrastructure development of which we're looking at further. And he's went on to talk about building a national data and digital twin initiative to bring models together about different systems, which I'll also again mention a little bit later. So clearly, the issues around computation and of infrastructure are clearly a very high profile. So they have a number of technical challenges that I think that people are experiencing on doing computation and modeling for infrastructure research. Firstly, scaling up, I think, is the problem across all research. We're getting more and more data, more high resolution is required. The computational processes and algorithms get more and more complex. We need more and more compute resources. So scaling up can be a big issue for different researchers. And then when we can scale up, we can get further opportunities. We want to do much more data integration. We want to be able to share data between our models. We want to be able to have allow common standards for that interchange and interoperation. And but we want to do it in a secure way where we can be as open as we need to be. But also when we need to have particular privacy or other commercial security implications, we can keep the security respected. So we need to be able to do that data integration in a principled way. And we also need to be able to integrate between models. And I think we're looking at where we integrate at different scales. So we got integration of models from at the top here, from an individual item of equipment right through to sites, organizations, regions, and the whole nation. So how you integrate different systems, different models together to deal with those different granularities of scale. And then we've got integration across sectors. As Brian mentioned, we're particularly looking at water, energy, land use, digital infrastructure, and transport systems and waste systems. But we want to integrate those sectors together, but also integrate with other areas where we have impact, like the environmental data or the economic and social data area, which we actually want to look for the impacts and risks in those areas. So a massive integration problem. Another aspect that I kind of very touched on in John Armitt's is digital twins. So digital twins is a model of which connects a physical asset to a digital asset, where you take observational outputs from the physical object, take it into the twin, see what might happen, and then put observations back into the physical twin. So you can use this for predictive asset maintenance, port planning, develop resilience, all these other things. And this means that another layer of complexity required, because a lot of real-time inputs from sensors and controls on the system, and then passing back the controls to the system. So digital twins is a massive area, and that's been reflected in this National Digital Twin Programme, which I won't go into today, but to building an ecosystem of sharing twins together. So that's a kind of a brief synopsis of some of the issues I'll be looking to. So let's move on to DAFNI itself. So as John mentioned, DAFNI is the data analytics, Brian mentioned, DAFNI is the data analytics facility for national infrastructure. So what we're looking at is providing a computing platform to support decision making for national infrastructure, and we're formed by a consortium of 12 universities led by the University of Oxford, Professor Jin Hall. Of course, UCL is also a member with Liz and Mike, and ourselves at the Multilateral Laboratory in Didcot on the Harvard campus as the host and development partner of the system. And this is an £8 million investment, started in 2017 and goes on till next year. Just a word about why we're involved. STFC, so we're one of the research councils. There's a very large multidisciplinary research centre, and we do support fundamental research in physical astronomy. But the other main role we have is in supporting and operating large-scale research infrastructures, typically very large instruments, Large Hadron Collider, telescopes, synchrotron sources, but also particularly in this context, computing and infrastructure. We operate at data centers at our sites for all kinds of different scientific projects, such as the Large Hadron Collider, and also relevant for this, the Jasmine super data cluster for climate research. So moving on to DAFNI itself, what actually is it? Well, we provide a hybrid high-performance computing platform as a hardware basis of what we do. And on top of that, we are building some extra systems to provide a secure repository for national infrastructure data from all different sources, and indeed models as well. And then using that data and models, we provide a platform to research and develop those models, so you can run those models on the high-performance computing platforms, share them, combine them together. So, and finally, it's kind of a place we see as a legacy place where we can make data and models available for long term. So we have a hardware platform with a dedicated high throughput computing cluster. Currently, it's got 27 server nodes, and which gives us 792 cores and about 2 petabytes of different types of storage, and that's in our machine room. And then I'm building that Kubernetes cluster to support the modeling, so we can give more computing power to applications. We can scale up, we can make them faster. And then on top of that, we have an infrastructure with a number of components, a national infrastructure database as our data store, a modeling service to support models, a cloud environment, some visualization tools, and this is all underpinned by a security infrastructure to keep the data safe as we need to. And that allows us to do various things. We can log into the system, of course, to use that security system. We can search for data through, upload and search for data through the data catalog. We can run models. We can then chain them together in workflow and do some visualization. So some of these things are going to be shown in more details in the demo. So what does this give us? Well, it gives us DAFNI as an information infrastructure. It gives us a data hub for data sharing, data integration, and data curation. So it gives a secure space where we can hold and access data, either importing from and linking to other data sources. Give us that integrated platform, which I said we needed in the beginning. So we can take energy data, but we can combine it with social economic data, and we can combine it with environmental data. And this is supported by a rich metadata framework, so we can represent the data well, to make it fair, to make it findable, accessible, interoperable, reusable. So it makes it available as a data hub for our user community, as open as possible, but at the same time as secure as necessary. And then the models thing, Tom will go about this a lot more later. We can then upload models from anywhere. We use Docker as a method of supporting models from anywhere, to some extent independent in code and some extent operating system. So that gives us a very flexible way of bringing different models written by different groups into the same platform. We can then run them on our HTC cluster using the Kubernetes system. allows us to scale up, to use the compute power available, access the data which we have in the data store, and give us more access to visualizations. And we can then build a repository of these models, a system called Harbor, which is a repository of these Docker containers, which allows people to share models and search models and reuse models that other people have made available, all within the same security framework as we had for the NID. And that's then, you know, I said we can allow workflows to be constructed. This allows us to chain models together. So you can chain, for example, a flood model with a transport model if you're interested in the impact of where floods might happen to rerouting your traffic system. You can couple couple models. This I think is a very important aspect of which I think it's going to be key if we're going to build one of this national ecosystems of linked twins. And I'll talk about a little bit later about a project that we're involved with, which is looking at it in more detail. Okay, just finally, in the last 3 or 4 minutes, I'll just quickly mention some examples. These are 2 examples of particular models that have been uploaded on the platform. So on the left is a model from the University of Southampton, which is on station demand. So this is looking at where you site railways. In this case, a example from South Wales, where you choose to place a new station on a railway line, and then you can look to see what happens to the catchment for that railway, where people travelling from to catch trains from that, where can you put the station to have the maximum impact, where will it, what impact will it have on neighbouring stations. And that came from Southampton, and one on the right is from the Simeon model from the University of Leeds, and this is looking at the impacts of changes of jobs and households, gross added values. This is sort of economic impact. A particular example of the looking at the Cambridge-Oxford corridor. So we put these on the platform that's successfully running and demonstrate the power which we can get from the system. I mentioned coupling models together. So I mentioned this program called the UK Infrastructure Transition Research Consortium, which is led by the University of Oxford, and they're producing a model called NISMOD as a National Systems of Systems model for energy, transport, digital, water and wastewater. Infrastructure planning. It's quite a complicated combined model with a number of different things linked together. And what we're particularly looking at climate risks, and what we're doing at the moment is migrating this onto our platform. It's kind of a bit of work in progress. It's still happening. It's nearly done, but so we hope to get that finished this summer. The key feature of this is the linking of models together and the mechanisms for dealing with the different resolutions in time and in space that a different model might have. So one may have a time step in hours, one having a different model may have a time step in days, and you need to be able to have those work together, and getting that to, that's a complicated system, and getting that to work is a real plus for us if we can do that. And the final examples, Brian mentioned the urban observatories, so we've started working at these, certainly the 6 existing ones, or the ones under development, where they are putting sensors around cities for things like floods and water and traffic and footfall and air quality and other things. Well, this is what we're looking at, is how we can best use that data. So this is where we've done some work at a hackathon, because we run hackathons, with a comparison between what the traffic from Newcastle and Sheffield at that time in the morning. So one advantage of having a central place is that we can bring the data from different urban observatories into the same place and compare them. The thing is, and this is kind of leads us on to the digital twin work, because this is about sensors, or from the environment, and then we need to bring that onto DAFNI in some sort of what we call fog computing sort of hierarchical way into the center, using data streaming systems. So we've got a real-time aspect. So this is kind of a good way to lead us into the digital twin space. So I think I'm nearly done. So just a final word, just to summarize what we have. So DAFNI provides an environment for research collaboration for developing infrastructure models. So we can bring together researchers, but also government and industry together to explore new ideas and modeling. So we've got this ecosystem that we, part of the ecosystem of this of infrastructure modeling, where we have this common HDC platform for scaling up. We can allow a data hub for data sharing within common standards and common infrastructure. We can scale up on a couple models and make them available. Hopefully we can work towards supporting the digital twin area with more real time and more streaming and more active involvement with the sensors, but also very much a legacy, a place for researchers to make their models and data available and shareable and for the long term, kept for the long term. So I think we in DAFNI we are making hope we're making a sustainable contribution to the infrastructure of our regional cities and rural areas. And so, thank you.